Today we are going to find the formula, derive the formula for the volume of a pyramid, so PYR, whose base is square. This is a square base. And the formula is gonna be the area of the base times the height squared divided by 3. Okay. So let us prove this. The proof relies heavily on the diagram. So suppose the base is b by b. And here's the top. Okay, so there's the pyramid. And from the top point right to the dead center of the square. Now, the top point is right above the center of the square. That there is the height. Now, what you need to figure out is, so we kind of know the formula. So for each slab, it's going to be, so let's call that delta V. It's going to be the base squared times, we'll call going up Z, times delta Z. But we need to know what the base is for any given height. In other words, for this slab up here, how long is this? I know all sides are the same, but how long is this if h is 1? If h is above 0? Well, what we know is this. When z is 0, so I'm just going to call this x. We know that the base x, because it's changing. At the bottom, it's b. So let me continue calling it b, but it's also an x value. And up here, it's also an x value. It's a little bit less. Up here, it's another x value. So when z is 0, that is, when we're at the bottom, the base, so let's define it. Well, the base is going to be b units long. And when z is at the top, when z is h at the top, up here, the square has sides of length 0. And what happens is, as we go up layer by layer by layer, first square, then a little bit smaller square above it, a little bit smaller square above that, a little bit smaller square above that, and eventually a really, really tiny square, and then at the top, at the tip, it's the square of where the base is 0. It's linear. It's changing linearly. So what we want to do is we want to find an equation. This tells me, and it's like I said, it's linear. This tells me that the point 0, b is on the line where the first coordinate is x, and z of course, and the second coordinate is x. And this point tells me this information, and it's a point. It tells me the point should be written this way. Okay, now let us find the equation of this line. You know that x is equal to mx plus, I'm not going to use b for this to define the slope, so I already am using the letter b. So we'll call it c. Now, what is the slope? Well, it's the change in the second coordinate, which happens to be x, divided by the change in the first coordinate, which is 0 minus h, which is b over negative h, which is negative b over h. So I basically claim I'm done because it's negative b over h times x plus the intercept. Well, that's the intercept. When the first coordinate is 0, the second coordinate is the intercept. And I do have one mistake here, so used to calling it x, but it's actually z. Okay. Now, let's just confirm that this is right. When z is 0, when z has a height of 0, we're down here, and the base should be b. Well, anything times 0 is 0, plus b, yeah, I get b. Wonderful. Now, when z is h, which is up here, because the height of this pyramid is h, up here, b should be 0, the very tip. So we get, using this formula, we get negative b over h times z, which is h. This canceled out, plus b. So we have negative b plus b is 0. So this equation is working perfectly. Just wanted to verify it. Now, the volume is equal to, well, it's gonna, the delta, hold on please. The thickness, since it's going up, that's gonna be delta z. And the limit becomes dz. And z goes from 0 to h. Now the area of each slab is gonna be base times base squared. It's going to be, maybe I should have said, it's going to be side by side. But each side is x. So it's going to be x squared. Okay? But x is a function of z. X changes as z goes from 0 to h. So basically, I am going to put in this for x. Is the integral from 0 to h of something squared. Now, I can factor out a b, and also, this is b minus. Rather have b minus rather than something minus b. Minus h over, got that completely wrong, b over hz. Now, I can factor out a b, and I'll have 1 minus z over h. So I'll have b times 1 minus z over h dz. And this b gets squared. And since it has nothing to do with z's, I can bring it in front of the integral sign. So it's the integral from 0 to h of 1 minus z over h squared dz. Now you can either square this or make a u substitution. For some reason, I am going to square it. So you get 1 squared minus the product, which is z over h, times 2. 2z over h, plus you get z over h squared, which is z squared over h squared. Integral dz. This is b squared. Now, I'm going to evaluate the integral. The integral of 1 dz is z minus the constant times z squared over 2 plus the constant. Integral of z squared is z cubed over 3. And we evaluate this as z goes from 0 to h. The one thing I would clean up is that these 2's cancel out to 0. So I have b squared. And one other thing I'm going to mention. These are the 3 terms, and in each of them is a z on top. When I plug in 0, I'm going to get 0. So I just really have to evaluate the top. I plug h in for z, I get h minus h squared over h plus h cubed over 3h squared. Okay, let's clean that up a little bit. B squared, this is h minus, that's also h, so that cancels out, plus 2 h's I kill on top, 2 h's I kill on the bottom. I get h over 3, and my answer is b squared times h over 3, which is b squared h over 3, which is, b was the base. So base squared times h over 3, which we'll denote as b squared h over 3, and I come up here and I go that, and I go, I had a mistake. Now, let's just call it big B. Big B is the base. Big B is the area of the base, where big B is the area of the base, better known as B squared. So I can just go right away to the final result, because I just said that little b squared, being the area of the base, is just called big B, h over 3. And that's the common way of writing the area, the volume of a pyramid. The area of the square base times h over 3. That finishes this video.